Okay, we should be good now, y'all. Okay, so y'all, in 2.4, hey, yes. Okay, thank you so much. Y'all, did you notice it when you came in? Right? It smelled a little funky. Okay, so hopefully, hopefully we're okay. But if something's going on, the culinary arts, y'all, is I want to say around here. And so if they're cooking stuff or you know what I mean, gas line, that kind of thing, they'll let us know. But let's just all be alert, right? If we start getting a little drowsy, maybe we should all leave. Okay, so y'all, 2.4 talks about measures of variation. One of them we've already talked about. We've already talked about the range. So y'all remember what the range is. We got a set of numbers, right? A whole bunch of numbers here. We take everybody's height and we put all of our heights in inches. And we wanted to find the range. We would say we're going to take the tallest person, we're going to take the least tallest person, we're going to subtract those numbers, and we're going to say everybody in this classroom has a height between, all right, or the heights vary between these two numbers, right? Nobody's going to be more than this or that away from their height. So, y'all, again, we've talked about range before. So, y'all, what we want to do here for these first two problems is we want to find, actually, let's just look at the picture. Find the range. So remember, y'all, the way we find the range is we're going to look for the biggest number, and then we're going to look for the smallest number, and we're going to subtract. Y'all, when we're trying to find the range, remember, we're talking about how old or young was a woman, what was a woman's age when they had their first child. I'm not really concerned about how many people had their first child at 24, or how many people had their first child. I just want to know the range in ages. What was the oldest woman here? 30, what? 34, right? And the youngest woman was, okay, so would you all agree that, y'all, our range is going to be 10? There we go, right? So again, part of it, y'all, is being able to interpret the information. A lot of times, sometimes people think, oh, I need to take the highest bar minus the smallest bar, but that's not what we're looking for. We're looking for the range and age, okay? Y'all, this is another dot plot, right? I'm not certain what this dot plot represents, but find the range. Okay, let's do this again, y'all. Let's look for two things. Let's find the max and let's find the min. It looks like the min is about 75, right? That looks like the dot on the smallest side. Yo, let's count over here. Look, if this is 95, that's got to be 96, 97. That looks like that is 98. Okay. So the range, y'all, if we were to take 98 minus 75, would that be something like 23? And we found our range, right? So again, I'm not counting like what's the most number of dots compared to the smallest number of dots. I'm looking on the, yes. Oh, let's see. In Spanish, we say alcanza. Yes, I do. Oh, there you go. Okay, so let's scroll back over here. And again, let's go ahead and find the range one more time. The depths in inches at which 10 artifacts are found, right? So we got a bunch of archaeologists out there. They got their little paintbrush, right? They're brushing away the stuff, right? We're digging down, trying to figure out if we can find certain artifacts. So let's see, y'all, my max number, doesn't that look like 46.7? And then our minimum, is it 25.1? That looks like the smallest one, doesn't it? I don't think we have anything smaller than that. Okay, so we're going to subtract 6, 1, 21.6, right? Okay, so now, y'all, we're going to talk about something that we call deviations. Okay, and when we talk about deviations, what we're going to do here, I'm going to kind of walk you through the process of what it is we're going to do. So let's take a look at this first part. and it says find the deviation of each starting salary for corporation B in the following example. So y'all, the information that they're giving us right here, these are the salaries for people, right? So we know how much. We have 10 employees. It looks like there's 10 employees. We know what their salary is. Yo, the first thing I would like for us to do, I would like for us to find the population mean. This is everybody who works in this company. I would like for us to go through and see if we can find what is the average salary. So y'all, there's a couple of ways we can go about, doing this. I'm going to grab my calculator, okay? And y'all, I'm basic calculator I have right here. Again, I did put the link for it for you guys as well. So look, let me clear this thing. Remember, we did this the other day, but again, as a refresher, I'm going to hit the button that says data. It's going to start off on my list, okay? So y'all, what I'm going to do here, let me see if I can move this guy over a little bit. Okay. Y'all, I'm keeping this as simple as I can. So when we say 55, we really mean 55,000, right? When I say 61, I really mean 61,000, okay? So let's enter those numbers in. So we got 55, 61. Again, y'all, we could add them all up and divide by 10, but we're going to be using the calculator pretty frequently, y'all. So one thing, I'm sorry, before I go on, one thing I would encourage you to do, I'm sorry. So y'all, my friend here has his calculator. He already has it with him. If you don't have a calculator with you, I would encourage you either to open up the computer so that you can use the calculator. I want you to get the experience. I want you to get the exposure of learning how to do it. If you downloaded one of those apps the other day, that's perfect too. But I want you to have the experience of being able to do it, because watching it is one thing, but watching it and then you're doing it too, that's going to be more like a tattoo up here in your medulla oblongata, okay? So the more that you actually do this yourself, the easier the process becomes. So again, you can open up your computer, y'all. What I would tell you to do, if you're going to use the computer, let me come back here. I'm sorry, I'm already here. If you're going to use your computer, y'all, if you log into Blackboard, again, I put links to both the scientific and the graphing calculator up here. And so you'll have access to both of those, okay? All right, let's see. So I did 51, I got to do what, 68? 68, okay. And then we have 59, and then we have 52, okay. And then we have 61, and then we have 63, and then we have 65, and there should be one more, 58. Okay, boom, there we go. Okay, so y'all, once I enter all those numbers in, the way I'm gonna get out of here, I'm just gonna hit second and I'm gonna hit quit, okay? Now, I wanna get to my statistics part, y'all. So I'm gonna go second and stats, and I'm gonna go to my one variable stats. My calculator's already highlighting that part. So y'all, I'm just gonna hit enter. I'm just gonna hit enter again until I get to the part that says calc, and I'm gonna hit enter one more time. Okay, yo, I know I talked about I'm looking for the little mu, right? The funny looking u here, which is the average. And my calculator, y'all, it's always going to write it as X with a bar, okay? But my average here, y'all, is 59.3. So this is what we're going to do. We're going to come back up here, and we're going to say the average is 59.3. What we want to do, y'all, what we're trying to do here at least, look, if we know what everybody makes and we know what the average salary is, could we figure out, say, some people make more than the average, some people make less than the average. Could we figure out, let's figure out who makes more, who makes less, and then let's find the average of those differences. You know what I mean? So like if you're making 60 something, is you're making more than the average. If you're making under 59, you're making less than the average. Let's find the average of those differences. So y'all, what we're gonna do here in this next column is we're gonna go 55 minus 59.3. We're gonna go 61 minus 59.3. Sorry. And we're going to take the difference from each of those numbers, y'all, to our average. And some of them, y'all, are going to be positive. And some of those numbers are going to be negative numbers, right? If we're making more than the average, it's going to be positive. If we're making less than the average, it's going to be negative. Okay. All righty, my friends. I got to come back here again. Boom. Let's do this. I'm going to X out of here. So I'm going to go second quit. And I'm just going to start subtracting. 55 minus 59.3. Oops, sorry. I put something wrong there. Boom, there we go. 59.3. Let's see. Negative 4.3. Okay. I'm going to keep repeating this process. Y'all, it's going to be a little tedious, okay? 61 minus 59.3. And y'all, I want you to do this along with me because, so like last night, and I had a class yesterday evening, a different class, and I was doing a calculation and I ended up typing in the wrong number. And then after class, somebody's like, sir, I got a different answer. It's like, what'd you get? And then I was checking and I was like, oh man, I wrote 300 or 270 and the number was 275. So I'm like, let me know, okay? So I just want you guys to check because, hey, look, I make a bunch of mistakes too, right? 8.7. 59 minus 59.3 should be a negative 0.3. All right, that one I can do in my head. Okay, 52 minus 59.3, negative 7.3. Oops, sorry, 7.3. Okay. All right, 61 minus 59.3, 1.7. 63 minus 59.3, 3.7. Almost done, my friends. Okay, 65 minus 59.3, 5.7. Okay. And then finally, y'all, one more. 58 minus 59.3, negative 1.3. Okay, so y'all, we got our numbers here, okay? If we wanted to find the average of those numbers on the far right, what should we do? How would we find the average of those numbers? Anybody know?
And then we have to divide by what?
By 10. Okay. We're going to do a couple more calculations. Guys, I'm doing this here because I want you to understand the process. Once we do this one here, I'm going to show you guys the shortcut, okay? But I want us to get through the idea of what it is we're trying to do. Okay, let me clear this. So look, negative 4.3 plus 1.7 plus negative 8.3 plus 8.7 plus negative 0.3 plus negative 7.3. Oops, 7.3. Be careful somewhere. Boom. Plus 1.7 plus 3.7. Okay. Okay, thank you much. Guys, if it does get too stinky, we can definitely do that, okay? Plus one more, negative 1.3. Okay, so we said, look, we're going to add up all these numbers. What? Do you see what happened here, y'all? We're trying to find the average of all those differences. But when we added all those numbers, we got what? We got 0. And if we divide it by 10, what are we still going to get? Man, okay. So you're like, really? Yes, really. So then, y'all, what we got to do is we say, look, what we're going to do, instead of us looking at these numbers here, we're going to square these numbers. Okay. So, y'all, I'm going to do the reason why I want to square them is if I square a number, whether it's positive or negative, the answer is going to be what? Positive, right? Because remember what it means to square a number. It means to multiply it by itself, right? So, like if we take the first one, negative 4.3 times another negative 4.3, it's going to be a positive something or another, right? And if the number is positive plus a positive times a positive, still positive. Okay. All right. Promise you guys, I'm gonna save you some time here. Okay. But this is what we're gonna do now. I'm gonna do this. Y'all, when I'm doing this here, like I'm not even gonna worry about the negatives because I know everything is gonna be positive anyway. So look, I'm gonna go 4.3. And there should be a little button around here that says squared. Boom, there it is. Let's hit enter. Okay, let me see. 18.49. All right, let's do this. 18.49. Okay, I'm going to keep playing this game here, my friends. Boom. I'm going to move this guy to the side so I can see what I got. Okay, let me do this. 1.7 squared is 2.89. All right, 8.3 squared. 8.3 squared is, I don't know, 60 something, 68.89. Okay, 8.7, I still got to do. Okay, 8.7 squared, 75.69. Yes. Okay, negative 0.3 squared, 0.3 squared, 0.09. Okay, 7.3 squared. 53.29. Okay, almost done, y'all. Boom. All right, 1.7 squared. 2.89. 3.7 squared. Oops, sorry. 3.7 squared is boom, 13.69. All right, two more, y'all. 5.7 squared, 32.49, and then finally 1.3 squared. Okay, 1.3 squared. Boom. Okay, 1.69. Okay, now, y'all, what I'm going to do here, I'm going to add up all these guys together. Okay, it's going to take me a minute, but we're going to do it. Let's go like this. Okay, 18.49 plus, so you can see everything, 2.89. 2.89 plus 68.89 plus 75.69 plus 0.09 plus 53.29 plus 2.89 plus 13.69 plus 32.49 plus 1.69. Boom. Okay. Did anybody come up with 270.1? Anybody come? Okay. Just making sure we're all coming up with the same thing. Okay. So look, y'all, when we start to square those numbers, okay, we came up with, I'm sorry, what was it? 270.1? Okay. Yeah. 270.1. 270.1. Okay. If we were to divide this number by 10, okay, if we were to take that number and we come back here and we divide it by 10, sorry, I want to say, y'all, we're going to get something like 27.01. That is going to give us something that we call the variance, okay? The variance is kind of close to the average of the differences, but the problem here, y'all, was when we try to add up all those numbers initially, we added them all up, all those differences, and it gave us a 0. So we weren't able to figure out the average. So when we squared those numbers, well, it really wasn't the difference. It was the squares of those differences. So we wanted to kind of figure out, okay, well, if we squared every number, and now we kind of want to get back to the original number, y'all. What we would do now is we would take the square root of that number right there. Okay. So I'm going to come back to my calculator again. And let's see. We had 27.01. And if we take the square root, by the way, y'all, if you're looking on your calculator right here, the way you'd find the square root, it's right above the x squared. Actually, I think what I need to do is I need to do that first. Boom, there we go. 27.01. So again, y'all, I just hit the second and then the x squared to give me my square root. We're going to hit enter. And y'all, I'm coming up with about 5.19, or I guess 5.20 if I round it 2 decimal places. So let's do that, 5.20. This right here, guys, a lot of little steps, right? A lot of little steps. This right here is what we call the population standard deviation. What that tells me is on average, every number differs from the whole average by about 5.20. That's what the average of those differences are. Okay. Now, y'all, I want to show you something here. I'm going to come back to my calculator again. I'm going to open it up all the way so you can see everything. Okay. Let me clear this here. Y'all, I want to go back to my stats button. I haven't, my numbers should still be there. So look, if I hit my data, it's all still there. Okay. So look, let's second quit. Let me go to my stat button. Okay. Just like we've been doing before, y'all, we're going to go to our one variable stats. Boom. We're going to keep hitting this calculate. Okay. We're going to scroll down, y'all. And I want you to look at this little symbol. This little symbol looks kind of like an O or like a 0, but he's sporting a little cap right there. I want you to look at that number right there. Isn't that the number we came up with a little while ago? Hey, so y'all, the reason I was kind of walking you through this process is so that we would understand what were we trying to do. We were saying, look, here's everybody's salary. The average salary was whatever happened to be 50 something, 51.9, whatever it was. How much does everybody differ from the average? And then we said, look, if I know some people make less, some people make more, what is the average of those numbers? But if we try to add them all up, we got 0. So we had to square those numbers, divided by however many we had. And then we took the square root, and that's the average of those differences. But now I know that anytime I'm going to do a problem like this, I'm not going to sit there and crunch a whole bunch of numbers. You know why? Because I told you guys, y'all, the calculator always tells me the correct value. The problem is I got big fat fingers. So when I'm doing this on my calculator and I'm hitting the button 5, I also hit the button 4 and sometimes 8, right? And sometimes 7 because I go like that, right? So I'm not going to worry about trying to do all these little minute calculations. It's going to take me forever. I'm going to use my calculator. Sound good? Okay. Those of you who use the graphing calculator, did it work out the same way? Worked out exactly the same way, right? So y'all, you have options here. The next problem, I'll do the graphing one so that you get the idea of like which one is it better, whichever one works for you. The one thing I want to make sure, y'all, if you're doing the app too, is find one of those that works best for you, okay? Especially, y'all, if you haven't used the calculator in a while, or we're doing stuff like this, like, Omar, I've never done this before. Y'all, trust me, before I took stats or taught stats, I hadn't done this before. So I taught stats for the first time in my 29 years of teaching right before the pandemic hit. I'd never taught stats before, right? I'd have been teaching like 22 years and I finally taught stats. So it was all brand new for me. I'd never used that stuff before, but now like, okay, it gets much easier, okay? So, all right. So y'all, what we're gonna do here for the second problem is we're going to find, okay, we kind of went through that process there. I'm going to kind of scroll down. This business right here, y'all, is kind of the process of what we did. Okay. Just kind of giving you the examples. Okay. So what we're going to,
There's 2 types of standard deviations.
One of them is called the population. So let me write down a couple of things for you guys. This little symbol right here, y'all, okay,
It's probably going to be like a little
X next to it. Okay. So up here, y'all, this little symbol, the little O with the X, by the way, this is a Greek letter. It's called sigma. It's the, when we did that big, kind of funny looking E, that's the capital sigma. This is the lowercase sigma, okay? That little symbol is what we call the population standard deviation. There's something called the population variance. If you remember a little while ago, when we took the differences, we add them all up, we got 0, so we said, let's square those numbers. We don't talk about the variance too much, but the way we got to the standard deviation is when we squared all those numbers and added them all up, that was the sum. All those numbers were squared and then we added them. So what we did is we took the square root, and that's how we're getting this number. We kind of start with the variance and then we get to the standard deviation. There's something called a sample standard deviation. And again, a sample just means like there was a bunch of numbers, we took part of them, right? So again, the process would still be the same. We would still do that whole squaring business and add them all up. And then we take the square root to find the standard deviation. So that's why sometimes you're going to see this little symbol, sometimes you're going to see that little symbol. When they're asking you for the variance is whatever number this is squared, okay? So look, do a question here, and we're going to pretty much do what we did right now.
It says a random sample of
10 college students. Oh, come on, let's come back here. Here we go. 10 college students withdrawn from a large university. Their ages are 22, 17, 27, 20, 23, 19, 24, 18, 19, and 24. Can we find the range, the mean, the variance, and the standard deviation of the sample set? Y'all, I know we can find the range real easy, breezy, cover girl. I'm going to show you a process, y'all, with our calculator again. Okay, so look, I'm going to come back over here. Y'all, I'm going to use this time, I'm going to use the graphing one, just so that those of you who are using the graphing one, again, you have some exposure to it, right? But the process works exactly the same way. Okay, so first thing I'm going to do, I'm going to clear my business out here. Now, on this calculator, when I want to make, so, and the scientific one, y'all, I was going to the data, right? Here, I'm going to do my list. So I'm actually going to go second and list, and I'm going to just click on the first one, list one, so I can just hit enter right there. Oh, wait, sorry. Boom, that's not what I got to do. Or is it stat, right? Edit, right? Sorry. Edit, there we go. Okay, we're going to edit our first list. Yes, thank you so much. Okay, so y'all, what we're going to start doing is we're going to enter these numbers. So we got 22, 17, and 27. So my first number, 22, go down, 17, go down, 27, go down, 20, boom, go down, 23, go down, boom, 19, go down, 24, go down, 18, go down, 19, go down, and 24, go down. Boom, there we go. Okay, all my numbers are in my list, okay? Y'all, I want to get out of this thing, so I'm going to go second and quit, okay? I'm going to come back to stats, and we're going to go to the menu that says calculate. So the easy way you can do that, you can just use your little arrow button right here, and we're going to calculate our one variable stats. So guys, you can just hit enter, boom. And I'm just going to kind of keep going down in my list. And when it says calculate, again, I'm going to hit enter, and it's going to give me a few things here, okay? So let's do this. The first thing, y'all, it's asking us is for the range. I know we can do that easy breezy cover girl. Y'all, do you see right here where it says minimum? Hey, that's the smallest number in my list. If I keep scrolling down, boom, there's the maximum. There's the biggest number in my list. So what do y'all think the range would be? If the biggest number was 27 and the smallest one was 17, it's got to be 10, right? All right, very good, y'all. So look, we're going to go range, boom, that's going to be 10. Awesome, very good. Thank you for your help. Okay, the mean. Y'all remember the mean, I know we're sometimes, Omar, is it X bar, is it mu? The mean is always going to be the same, okay? Since we are, y'all, one thing I want to mention here, since we are referring to sample, that's the symbol we're going to use, the little X bar. Okay. The value would never change, but that's the symbol I'm going to use. Okay. What was my X bar here? 21.3. There you go. 21.3. Okay. Y'all, I'm referring to samples. So when we're looking for variance, we're looking for this number being squared. And when we're looking for standard deviation, we're looking for that little symbol. Again, the reason being, the word that they used here was the word sample. My friends, I'm going to come back to my calculator again. I need to look for the SX because that right there is my sample standard deviation, right? And because they use the word sample, that's the one I want to use. If they would have used the word population, then I would have used that little OX. Does that make sense? Okay, so look, y'all, what I'm going to do here, I'm going to say, look, that looks at what, about 3.20? Let's go 3.20. I'm going to write that in for that number. Now, I still got to find this number. But the difference between this guy and this guy here is that I just got to square that guy to get to my answer. So y'all, what I'm going to do now, I'm going to come back here. Let me get out of this business. And let's say, what's 3.20 when you square it? I don't know, 9 and change? 10.24. Boom, there you go. And you're done. My friends, the one thing that I am going to advocate for is to get comfortable with using the calculator, whether you're going with the regular scientific calculator or whether you're going with the graphing calculator or whether you're using one of those apps, okay? You want to get comfortable with it because you could see with that first problem, y'all, with the salaries, me trying to compute everything by hand, y'all. So think about like when I was in school, actually my stats professor, I went to UTPA, right? My stats professor, I ran into him at Walgreens like a couple of months ago, right? He's still there, right? He's still there. He's retiring. He says he's retiring at the end of this year. Y'all, when I took him for stats, all that stuff we did, I still have an old notebook somewhere at home. Y'all, like just so much little calculations everywhere, right? And you can see my handwriting. It hasn't gotten better over the last 52 years, right? So it's still, and I'm like, man, how did we do that, right? It was a pain. And y'all, using the calculator, it just makes these processes so much easier, okay? So I really do want to advocate for that, okay? Y'all, let's do another problem here. And again, y'all, I'm calculator, again, to give us the exposure, to give us the experience, okay? Look what it tells me here. It says the numbers of regular season wins for 10 football teams in a given season are given below. Can, again, we find same things, range, mean, variance, standard deviation. Y'all, keyword here, population, okay? We're going to do the process, so exactly the same way, my friends. So look, let me come back here. Let me clear this out, okay? Guys, I'm going to stick with this calculator for right now. And I want to show you guys something. If I go to stat and I want to say edit, and suppose like you're like, Omar, I still have all those numbers there. How do I get rid of them? Come back here to the top where you've highlighted list one, hit the button that says clear, and then hit enter, and it cleared out all those numbers for you, right? And the reason I say that, y'all, is last year when I taught this class, I had people, see how like some people would say, I'm just going to go to list 2. And by the end of the semester, they were like list 79 or something like that, right? Like, oh man, it's too many lists, right? Let's clear this stuff out. All right, guys. So let's make this easy breezy cover go. 2, 10, 15, 2 again, 14, 6, 14 again, 10 one more time, 2 one more time, and 9. Boom. There we go. Okay. Now I want to get out of here, y'all. So I'm going to go second quit. I come back to my stats. I'm going to scroll over to it says calculate, and I'm going to do my one variable stats, right? So I'm just going to hit number 1. Boom. And y'all, you can either just hit enter or you can just scroll down, Charlie Brown, until you get to calculate. Okay. And then we're going to hit enter, and boom, we came up with a whole bunch of numbers. Okay. So y'all, if I look at my directions here, first thing they're asking me for is the range, right? So again, I mean, I know you can look at the stuff there, y'all, but if you see it here, the numbers are there, they're organized for us. If I was interested in my range, we're going to take the biggest number minus the smallest number. The biggest number is 15. The smallest one is 2. Everybody agree the range is 13? Okay. Next thing is the mean. So y'all, this is when you're doing this in MyLab, that's going to be the little symbol that's going to pop up because the word they used was population. But when you go to your calculator, you're still looking for the X bar. That number never changes, okay? So it's still 8.4. Okay. The next thing, y'all, this is how it's going to be written in MyLab. They're going to ask you, what is the variance? This symbol right here, y'all, is my variance. So let me do it like this. Let's go like that. Variance, and what I'll do to make it easier, make it easier, breezier, cover girl for you, boom, I'll put it in purple, okay? I don't know what my variance is, but I bet you I do know what my standard deviation is. So I know this number right here, guys, is going to be 4.9. So I'm going to write 4.9 right there. But in order for me to find my variance, I'm just going to get out of here real quick. And I'm going to say, hey, Omar, what's 4.9 when you square it? 24.01. Yo, not to lose, I mean, the important thing here is to make sure that you know how to use your calculator, know how to do the calculations. To not lose sight on what does this mean? These were the number of wins for 10 football teams. Okay, so we said, look, let's take a look at the Valley, right? Let's look at the small districts, Santa Maria, La Villa, right? Stuff like that. Santa Rosa, right? Real small districts. Let's look at San Isidro. I don't even think they have a school. But we were looking at how many games did they win, right? Some teams won 15 games. Some teams only won 2, right? So we said, let's find the average. The average number of wins was 8.4. How much did every team differ from the 8.4? We found those numbers. And we said, let's find the average of that. When we found the average of that, y'all, the average of the difference in the number of wins was about 4.9, right? That's really what that standard deviation is kind of telling us there, okay? All right, let's try one more, y'all, and then we'll do some interpreting. Okay, what is all this kind of stuff? What does it really mean visually and all that kind of stuff? So y'all, it says here, the ages in a random keyword, my friends, sample, okay? Of shoppers at a given store are shown. Determine the range, mean, variance, standard deviation of the sample data set. Okay, guys, I'm going to do the same thing here. The only thing, my friends, I'm going to do different is I'm going to go back old school. I'm going to use this guy right here. So again, those of you who are using, you have experience or exposure to both of them, okay? Let me clear this out. Y'all, if I come back to my data, again, for whatever reason, I know I had used it earlier and I had a bunch of numbers there. You should be able to clear that out the same way, okay? But look, let's enter our numbers. 12. Let's go 18. Okay, let's go 23. Let's go 15. Let's go 21 and 17 and 22 and 18 and 15 and 18 again. Boom. There we go. Boom. All right, we got it. Y'all want to get out of here? Second quit. I want to get to my stats feature. So I'm going to go second stats from here. And I'm just going to go to enter on number 1 and scroll down till I hit calculate or hit enter. Boom. And let's figure out what we got. Okay, y'all, first thing again, just like it was before, it's asked me for the range. Let's find the range. Remember, y'all, the range is the smallest or the biggest number minus the smallest. So the biggest number, was 23. Smallest was 12. 23 minus 12 should be 11. Okay. Second thing it's going to ask me for is the mean. Y'all, since they're using the word sample, when you get to MyLab, that's the little symbol you're going to see. It's going to be a little X bar, which again, it doesn't really matter which one you're doing, but the X bar here should have been what? 17.9? Okay, 17.9. Okay. variance and standard deviation. Since we are talking about a sample, those are the symbols that I'm going to look for on a calculator. So y'all, I'm going to scroll right here. Okay, look, I found the sample standard deviation, 3.4. Y'all, I want to say that when you're doing this in my lab, for this guy, they're going to ask you to go to just. So if I'm looking at the 3.41, I would say, hey, that number is closer to 3.4. Okay. Now, to find the variance, y'all, I'm just going to come back to my calculator again. Let me get out of here. Boom. And let's take 3.4 and let's square it, right? 3.4. Boom. Hit the little button that says square. Hit enter. And this one, it is going to ask you to go 2 decimal places. You're already there. 11.56. Guys, what do you think? Is this something like if you had these problems in your homework, could you do them? Good. That's the point, y'all. That's the point. The more practice that you do, the more comfortable you get with the calculator, the easier it's going to become. Okay. So again, if you have any hesitations, don't worry about it, guys. Come sit down with me after class. I'm happy to help you guys out. Okay. All right. So, y'all, it says when interpreting standard deviation, remember, this is a measure of the typical amount of entry deviates from the mean. The more entries are spread out, the greater the standard deviation. So like y'all, in this problem here, my standard deviation, let's see, not this one here. The average was 8.4. But do you see how like we had some teams only won 2 games? I mean, that's a pretty big spread, right? Some teams won 15 games. That's a pretty big spread. So the bigger the spread, that means that my standard deviation is going to be a bigger number. If my numbers are closer enough together, then my standard deviation now becomes a smaller number, because what we're saying is it didn't really change that much. Everybody made about the same. Everybody won about the same number of games, okay? So, y'all, we're going to do something here called the empirical rule. We call it the 68, 95, 99.7 rule. And so we're going to talk about something called a bell-shaped distribution.
As for data,
It says when we have a symmetric or a bell-shaped distribution, the standard deviation has the following characteristics. About 68 lies within 1 standard deviation of the mean. About 95% of the data lies within 2 standard deviations of the mean, and about 99.7% of the data is going to lie within 3 standard deviations of the mean. So, y'all, what we're going to do here is something a little different from what you kind of have in your notes. So, y'all, I did put a link to it in Blackboard, and what I did was last year when I taught this class and I was covering this stuff here, I said, you know what, it's going to make this easier. Yo, this handout that I'm giving you, it's the same problems that you have there in 2.4. It's just what I did is I included the picture of that bell-shaped curve under every one of these questions, because I think it makes the process to be easier on how to do these kind of problems. Well, you're welcome. Let's go. And I will put them up here in case anybody needs another one or somebody else comes in later, whatever happens to be. Oh, extra? Thank you, thank you, thank you. Okay, so y'all, let me do this real quick. Let me come back over here. Extra, thank you. And what I'm going to do, y'all, where's my stats folder? This is us. Oh, Bell State distribution. This is us. What's going on? Okay, here we go. Okay, and let me throw this guy up on OneNote, y'all, real quick. This is okay. So guys, it's the same thing, but you guys have the same thing we had.
Notes that I had in the rest of
T4.
Okay, so let's take a look and let's see if we can figure out
What we're trying to do here. All right, so it says, use the empirical rule. The mean speed of a sample of vehicles along a stretch of highway is 66 miles an hour. Okay, right there, y'all. I'm going to read that sentence. I'm going to highlight it, and I'm going to write something down. Okay, what I'm going to write down, y'all, they're telling me that my X bar, because that's my mean, is 66 miles an hour. Okay, y'all, I want you to do me a favor. I want you to look at the picture. Do you see in the middle of the picture, there's an X bar at the bottom? Okay, what we're going to do, y'all, we're going to write the number 66 right here. Okay. The next thing they're telling me is we have a standard deviation of 5 miles an hour. Y'all, because we're talking about a sample, the little symbol that we used was the S. They're telling me that that number is 5 miles an hour. Okay, y'all, this is what we're going to do now. I want you to notice right under here, they are adding this number to the mean. So if we have 66 and we were to add 5 more, what number would I write down there? 71. Y'all, if I were to add S again, so I'm just going to keep adding S. I'm going to keep adding that number. 71. If we added another 5, everybody agree? And then over here, y'all, wouldn't that be 81? Okay, my friends, we're going to do the same thing going this way, but we're going to start subtracting. So if we had 66 and we subtracted 5, how much would we get? 61? Okay. And if we had 61 and we subtracted 5, would y'all agree 56? And then if we had 56 and we subtracted 1, would you guys agree 51? Okay. Now, the reason why I want us to do that is when I look at the next part right here, where it says estimate the percent of vehicles whose speeds are between 51 miles an hour and 81 miles an hour. Look, y'all, here's 51, here's 81. And I want to know what percent falls within that range. What percent would you say? Wouldn't we say 99.7%? Because here's the 51, here's the 81. I'm just going up. And when we're looking at all three, everything in there falls within 99.7% of my numbers. Does that make sense? So, y'all, the reason why I handout here was in the notes. Y'all, I think I had like one picture, but what I did here for the notes is I included that picture every time. And guys, I'm going to play that same game. But then when you get to your homework, and if anybody wants an extra copy, I'll leave them up here. But what you would do in your homework, they may not give you the picture, but you can use like the picture and write your little numbers. You see what I'm saying? And I think it makes it easier, breezier, cover girl. Look, let's try another one. Okay. Oh, so there, I'm sorry, the answer was right here, 99.7. So that's what I'm going to write. Boom, 99 points. That's supposed to be a point. 0.7, right? The percent sign is already there. You don't got to write it. All righty. Let's do this, y'all. Let's look at this guy. Okay. Let's take a look. It says the mean value of land and buildings per acre from a sample of farms is 1,800. Okay, y'all, first thing I'm going to do, I'm going to write X bar. That's my mean is $1,800. Okay. With a standard deviation of $300. So y'all, just like we did before, right here in the middle, I'm going to write 1,800. Okay. If anybody has a calculator, guys, I'm going to ask you to help me so I don't have to keep going back and forth. Let's start adding 300 to that 1,800 as we go to the right. If we had 1,800 and we added another 3, would that be 2,100? And if we added another 3, would that be 2,400? And if we added 3 again, would that be 27? Okay. Now we're going to go to the left, y'all. So now we're going to start subtracting. My friends, if I had 1,800 and I gave you 300, I would be left with 15, right? And if I gave another 3, we'd be left with 12. And if we gave another 3, we'd be left with Okay. Y'all, there's another piece of information that they gave me right here. It says, assume the number of farms in the sample is 70. What that tells me, my number N, y'all, is 70. There's 70 farms. I'm going to use that in a little bit. Let's see if we can do the first part, though. The first part says, can we use the empirical rule to estimate the number of farms whose land and building values are between 1,200 and 2,400? Look, y'all, here's 1,200, here's 24. Y'all, I'm going to go up here, and I'm going to go up here. What percent falls in that range? 95%. Okay, so look, y'all, I'm going to write 95%. As a decimal, 0.95, right? That's how we write from percents to decimals. We just move the decimal 2 spaces over. Now, y'all, the question that they're actually asking me to find is how many farms, right? So we need to find, y'all, 95% of how many farms were there? 70. Okay, can somebody do me a small favor? And y'all, look what it says right here, round to the nearest whole number. Y'all, if you take your calculator and you take 0.95 and you multiply it by 70, what number did you come up with exactly like on your calculator? 60, what? I'm sorry? 66 point something? 66.5. So what would you say? Would you say 66 or 67? 67, right? We're going to round it up. Boom. There you go. Yo, is this handout, is this like with the graphs, is that helping? Makes it pretty easy, right? Like, oh, watch us, sir, right? I know you didn't say watch us, sir. I'm just kidding you. Okay, now let's take a look at part B. Part B says, if 26 additional farms were sampled, how many of those farms would have landed in that same range? So now, y'all, they're saying, okay, now we're looking at 26 additional farms. How many of these additional farms? So, y'all, I'm going to do the same thing, but look, we're just going to go 0.95 times 26, right? Now we're talking about an additional 26 farms. What number are you coming up with? And if you round it, y'all, to what? If you were to take 0.95 times 26 and you round up, what do you come up with? 25? There you go. And look what it says, y'all. 25 farms out of the 26. Sometimes people ask, I'm not supposed to add it to the 70. No, they're just talking about that additional part. Okay. All right. Look, y'all, let's kind of keep moving along here. Anybody here going into the social sciences, sociology, psychology, anything like that? No? Oh, yes, one? Okay. So we got some people going to social sciences. Y'all, stats is used a lot in healthcare. Anybody going into healthcare? Okay, a few of us. Okay, very good. Y'all, stats is used a lot in healthcare as well as the social sciences, okay? I'll tell you right now, y'all, I was working with a professor in psychology, and man, her stats background blows me out of the water. Okay, let's take a look here. The mean IQ score of adults is 100. First thing I'm gonna write, y'all, my X bar is 100. So I'm gonna put a 100, boom, right there. With a standard deviation of 15. Okay, we're gonna start adding. Everybody agree 115, 130, 145, right? Okay, we're gonna start subtracting. 100 minus 15, 85. If we subtract 15, 70, 70, right? And if we subtract 15 again, wouldn't that be 55? Okay, look, y'all, use the empirical rule. They're only asking me for the percentage between 70 and 30. Here's 70, I'm sorry, and 130. If I look at this percentage, you guys would say 95%. Okay, y'all, let's try another one here. The mean score of a placement exam for an entrance is 80. Okay, so first thing I'm going to do, y'all, X bar is 80. Down here, my friends, 80. Standard deviation, my S value is 10. So again, I'm going to start adding 10. 90, 100, 110, 70, 60, 50. Okay, now let's take a look what it says. Can we find the percentage of scores that lie between 60 and 80? Okay, y'all. So look, here's 60, here's 80. Y'all, I'm looking for everybody within this piece. What two percentages do you think I need to add together? 34 and 13.5. And are we all coming up with 47.5%? Boom. Okay, so y'all, look, let's scroll down a little further, and I think I got two more. One more, and then we'll do one, y'all, out of the actual notes, because I want to do one more that's in the notes, because I think you have something similar to that in your homework. Okay, mean score of a competency test is 78. First thing I'm going to write down, X bar is 78. Standard deviation is 4, so here's a 78. This should be 82, 86, and 88. And if I start to subtract 74, 70, 66, 90. I'm sorry, you're right. You're right. You're right. Sorry, guys. Boom, 90. Thank you. Okay, y'all, we want to look for scores between percentage again, between 70 and 86. Here's 70, here's 86. If I go up, oh man, that's an easy breezy cover girl problem. 95%, right? Boom. There you go. Okay, so y'all, what I want to do real quick, I want to do one of the questions, because we pretty much did the questions that we did the questions that were in our notes, right? Look, we did the farms, right? We did this, we did that. We could do the same thing here with the pregnancy, right? The process would be the same. Y'all, what I want to do, let me see if I can find it. Here we go. This is the last question I want us to do, y'all. It's similar to the one that we did. So actually, let me do this. Mm-hmm. Okay, let's go like this. Boom. Here we go. Okay, so I'm gonna use that graph, y'all, for a little bit, and I want to do this one right here. And let's see. Okay, so look at the problem, y'all. It says the mean value of land and buildings per acre from sample farms is 1,300. Okay, y'all, just like we've been doing before, I'm going to do this problem the same way we've been doing all the others. It said my X bar was 1,300. So right here, I'm going to write 1,300. What else do we know? Standard deviation is 200. So my standard deviation is 200. So y'all, this number here should be 15, 17, 19, right? If we start to subtract 1,100, 900, 700, right? Okay, I'm going to come look at my picture. Look at the question that they're asking me. Which of the farms are unusual? Now, y'all, they're going to define what does it mean to be unusual. It's going to be then 2 standard deviations from the mean. So what do we really mean by that? More than 2. So look, y'all, this was my X bar. More than 2 is going to fall this way and is going to fall that way. So it needs to be more than 1,700 and less than 9. Okay, so let's go back. Let's look at the picture. Do we have any numbers that are more than 1,700? More than 1,700? This guy right here, right? Boom. Okay, look, it says select all that apply, right? So there's that guy right there. Do we have any numbers that are smaller than, what was it, 900? The 628. Boom. Does that make sense on what we did? Okay. Is there any more to that question? Here we go. Now let's look. Okay, there's a part B to that question. Which of the farms are very unusual, more than 3 standard deviations from the mean? Okay, so I'm going to come back over here. Okay, now if we're talking about very unusual, y'all, we want to know more than 1900 and less than 700, right? Because that's going to be very unusual, more outside of those ranges. Okay. Did we have any numbers more than 1900? No. Did we have any numbers that were less than 700? The 628. Boom. And there you go. Now, y'all, the last thing I'm going to tell you is this. Let me come back. Boom, right over here. Okay, come back here. Here we go. Yo, when you start doing your homework out at 2.4, and I'm going to let this guy load up. It should have popped up already. Here we go. Oh, come on. Okay. And you get to questions like, I don't know, I'm going to pick 14. I have no idea what 14 is, but I'm going to assume it's something like this. Okay. When you get to something like this, again, it's up to you. But if I were sitting where you're sitting, what I would do is I'd have this guy right here, right? I'd have this guy right here. Boom. And I would just, again, if you want extra copies of that stuff, guys, are up there. But what I would do if I was sitting where you're sitting, if I was doing this problem, again, notice they don't give me the picture, right? But the first thing I do is say, look, my middle number, 465, and I'm going to start adding 95, and I'm going to start subtracting 95. Does that make sense? And then that's how I would approach the problem. That's why I gave you guys that handout, because I think it makes that process smooth. Okay. Y'all, that's it for us today. We finished up 2-3 and we knocked out 2-4. Okay. So y'all, let's do this. Let's see. Was it still recording? Oh, it did.